Hello, my name is Richard Anthony Marca, and this is my CSC421 Homework 7 Machine Learning Shallow Learning Tutorial. As you can see, all of the fields have been done, and I will go through each one at a time to show exactly what I did and what we learned. So the first step is to mount the Google Drive to access the files. So let's do that. Connect to Google Drive. That's the Google thing I'm using, so I'll continue. And there you go, it's mounted. And if I do Control Enter, now we could see what's in the drive. And in the collab notebooks, which I'm using, we have the confusion matrix pretty print Python file and the iris data. So actually, if I open the iris data, here is all the things for the flowers in order. And here is the confusion matrix to make it look nice, which we'll show at the end. And I will do this part as well. Drive's already mounted. And this is to get the two files. Now I did change it from collab space notebooks to collab underscore notebooks because it looked like it was not working correctly with the space. It just looks nice with the whole thing underlined showing it's one file. And the tutorial showed these installs, but I already have these installs, as you can see down here. Now, for some reason, it says that this could not be resolved, but it does resolve because it does work, which I will show at the end. So here are all the imports we used. And this is going to be the output for the numerical data. So if I run this, you're going to see the sepal length, the sepal width, the petal length, and the petal width, and all the counts for them. This will be for the custom labels. So if you look at the iris data, we have iris setosa, iris versicolor, and iris virginica. And this is to help with the label encoder. So now, as you can see with this, it has the array output, which is what it's supposed to be. If I did iris describe, it would actually describe what the array is. So if I actually did comment this out like it showed there, you actually have basically the same thing as before, but we don't want that. We want this to be an actual array. So there you go, there's the array. This is to filter the data, which they have commented out because they didn't want us to really filter it based off of certain labels, but it does work. This is to randomize the data because it's not going to be very useful if it's always the same list. So if I run this, nothing's going to happen because it's commented. So if I click the randomized data, you're going to see that the randomized data is now been created. So if I open this file, and let's put it down here, you're going to see that this is different than this. First, it doesn't have the labels of the names, but also the numbers are a different order. For example, the first sepal length is 5.1, while this first sepal length is 4.9. And if I run it again, well, now you're going to see that it's 5.4. It actually changes every time I run this. And here is to get the data frames for each of the four features. So the sepal length, sepal width, petal length, and petal width, where we could combine the sepal area and make as a process data. So if I actually run this, you don't see anything outputted here, but it does affect the backend for later methods. So here's the percentage training data and percentage validation data, where we separate the data into two sets. So I do this. And these could be changed. So we're having only 80% of the data be considered training and the rest are the validation. If we go down here, this is more separations for examples, all features, training, and validation. And this is to print to make sure what we did actually works. Because if I just ran these, there is no output. But if I actually run this, you're going to see the output. It looks really nice over here where we have, scroll up a little bit, 150 total examples, which they are 150 because the 151, the first one is just the descriptions. So 1 to 151. And 80% are examples for training, which now that I look, I made a typo. I did font training. It needs to be 4. So let me just change that. That's not a big deal. It's just a little typo, but now it's fixed. And if you look, here are the training features summary and the validation features summary, which are both separate. And here are the training targets / labels summary and the validation targets and / label summary. Let's go to the next part, which is more display data checks. If I actually run this, you're going to see the training feature summaries that display. So the count is 120. And these are the summaries for each of the counts, normalized, which is separated by the 5 CV folds from earlier. Kind of odd that these ones say 1.2 e to the 2 when that's just 120, but I guess it really wants them like that while this one stays at 30. Anyways, this is to generate the machine learning models and make predictions. So we're going to have 2 models, logistic regression and support vector classifier. So if I run this, it's going to create the models, and this will print the model parameters. So as you can see, we got the logistic. This looks different than the one they had because theirs gave a bunch of extra stuff for it. Also, this was depreciated, so they don't use multi-class in multinomial because that is what it starts with now. If I do make the predictions, here are the predictions. As you can see in this prediction, well, it's actually off a little bit. For example, here they have a 2, but it's actually a 1. Here they have a 2, and it's supposed to be a 1. Here they have a 2, it's supposed to be a 1. So it is off slightly, which shows it's not perfect. For the formatted results, I run this, creates the confusion matrix, and then it's going to display the basic summary. So overall prediction for the logistic regression prediction accuracy is overall 90%. And the thing that they keep messing up with is the versicolor. It also gives the results for classic 5-fold cross validation with an overall 95.33%. So while it seems that the support vector classifier is exactly the same, the overall for the 5-fold cross validation is actually slightly better. And if we want to display the confusion matrices, we run this last part. And compared to the video lecture, it's different colors because I'm in dark mode. So it's more pinkish. But as you can see, these are the predicted and the actuals with the versicolor. If I exit out of these, it shows for the Setosa and the versicolor that it's 100% accurate. But there were 3 anomalies, which shows this is only 75% accurate, dropping it down to a 90% accuracy. And same with the support modifier. That is everything from this video lecture. Thank you, and I will see you next time.